So before we get started on this foldable, I want to go over exactly what we're going to be doing today. We are doing similarity proofs. Yes, we're doing proofs, but it's okay. It's okay because what do you think have we done in the past that could be similar to similarity proofs? We have done congruence proofs, right? And remember, what is congruent? Yes, same size and also same shape. And what is similar?
When they have the same shape.
When they just have the same shape. So, if you can show two shapes are congruent, what else are they?
Similar.
They have to also be similar. So, a lot of proving shapes similar is just basically proving the shapes are congruent. Now, there is one circumstance, one time, when a shape is just similar and not also congruent. And that is when we have what is in this foldable. So if you remember, what were the two congruence, the two things that did not prove congruence? ASS and AAA, right? Because remember, we could have a triangle that has 60, 60, 60, right? And then we could have a much larger triangle that is 60, 60, 60. Were these two triangles congruent? No, but what are they? Similar, because similar is just same shape. Now, the reason in our foldable that it is just angle, angle, is because, say I have this triangle that has a 30, 60, and then I have this triangle that also has a 30, 60. What does this angle have to be? 90. And what does this angle have to be? 90. Did I need those two angles? They can only possibly be one value, right? So you actually only need two angles shown to be congruent, because the third angle has to be congruent no matter what. So that's why you don't need three angles in this postulate. You just need two, angle, angle. So we're introducing the one similarity postulate. The rest of the postulates are technically termed congruence postulates that also work for similarity. But this is the one that only works for similarity, and it is angle, angle. So first we're going to define angle, angle. So on this flap, this angle, angle flap, you're going to write if, and you can write it slanted. I'm just, obviously it doesn't project very well. If two angles, and I'm going to use symbols for everything because I'm lazy. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. And if you still don't know what that squiggly line means, I would put an arrow and write similar. So if we have two angles of one triangle congruent to two angles on another triangle, are those triangles congruent? Are they? No. If we have two angles of one triangle congruent to two angles of another, are therefore those two triangles congruent? No, they could be, but we don't have enough info, right? But we do know that they're always similar. Okay. So let's try, everyone got that down? Okay, let's try applying this to some examples now. All right, example number 1. Determine whether the triangles are similar. If they are, write a similarity statement, explain your reasoning. Now, like I said, proving triangles similar is extremely similar to proving triangles congruent. So, how did we start off proving triangles congruent? Mark your picture with the given. Obviously, did it give us anything here? No, so there's nothing to mark. However, what do I then need to check for? I need to check for what are the parts that they don't tell us are congruent, but we can mark as congruent. Who did? What 3 things do we need to check for? Vertical angles, reflexive sides, and now we can actually have reflexive angles. They could share the same angle, and also parallel lines. Do we have any of those in this picture? No. So we can now do what? No. What do we do after we marked parts congruent? We label with A's and S's. So on A, I put an angle, Z, I put an angle, CB, I put aside, and YX, I put aside. So how do these triangles read? AS. Is that a congruence postulate? Is that a similarity postulate? So what do you think I'm going to write here? Not enough info. Shh. Not enough info. Any questions on that one? Pretty straightforward, right? Okay. Number 2. Shh. We're again asked to determine whether the triangles are similar. If they are, write a similarity statement, explain your reasoning. So, first, we mark the given. Obviously, there's nothing given here, so we check for what? Vertical angles. Are there vertical angles? Oh, why, yes, there are right here. Is there anything else that's congruent that it didn't mark? Nope, there's no parallel lines or reflexive sides or angles. So now we can mark with A's and S's. How do both of these triangles read? AA. So are these triangles similar? Yes, they are, by the AA postulate. And then it says write a similarity statement. What do you think that is?
Triangle BAC and triangle BEC.
Right. Yeah, triangle BAC is similar to triangle. Now B corresponds to D, A corresponds to E, and C corresponds to itself, C.
Back to back. Back to deck. Back to deck. No. What?
Is this all, is it coming back to you slowly, how we did congruence proofs? Hopefully. Okay.
Oh.
Lastly, number 3.
Is it like a porcupine or like a sloth?
I would put a star on number 3. And again, it asks us to determine if these triangles are similar. If they are, write a similarity statement. So, what parts do we know are congruent? So look here. We have 2 parallel lines, right? We have AB and we have DE. They are parallel to each other. Then if we take BE or BC as our transversal, right? Our transversal cutting 2 parallel lines, we know that corresponding angles are congruent. Now, corresponding angles, how could you describe those angles?
Same.
They're where compared to each other?
Oh, next to each other?
Right. If we put this top grouping of angles on top of the bottom grouping, corresponding angles would lie right on top of each other. They're in the same position. So here, angle B is congruent to angle DEC because of corresponding angles. or the corresponding angle postulate. And then the same thing for A and EDC, right? There's also one other angle we know is congruent. We don't need more, right? We just need two angles, but there is one more. Why is C one of our angles? Ah, there are two triangles here, right? The smaller one that is inside of the bigger one. And both of them share that top C angle. C is congruent to itself. This is called the reflexive property. Remember, we used it a lot in congruent triangles with the reflexive side. Remember that? Where two triangles shared a side. Now they can also share an angle. So, yes, C is congruent to itself by the reflexive property. So, how are these two triangles similar? By, again, AA. And what is our similarity postulate? ABC is similar to triangle DEC. Good. Why do you think we put a star by that one? Ah, so I'm going to ask you to write a two-column proof, and it may be using this concept right here.
What are the chances that it's using this concept? Pretty high.
Fairly high. All right, I want you now to glue this in on page 37, and I want you to glue it kind of near the top. Enough room so you can still write a title, but you need room to write the congruence postulates below it. Okay? Yes. Yes.
No, I did it wrong.
So if this is our page, you need enough room at the top to write page 37, and that this is similarity postulates. And then at the bottom, oh, I'll make that font bigger, I'm sorry. And then at the bottom, you're going to write congruence postulates. Shh. Congruence postulates that also prove similarity. Someone give me one of the congruence postulates. So that's a similarity postulate. ASA is one. SSS is one. SAS.
Is this what we're writing?
This is what you're writing, yeah? And then what? AAS, yes. And the fifth? No. Nope. SAS is there. HL, yes. HL. Everyone forgets about HL. And what is the one that does not prove congruence or similarity? ASS.
That's a bad word.
Yes, it is a bad word. Hopefully it helps you remember it. So the reason we're going over this is because all of these postulates also prove similarity, okay?